Hi guys. Um, we're gonna try this problem. This problem is fairly unique. Uh, this is a continuation of the little challenge I've been doing where I'm doing a ton of problems of this one competition, going through the entire year's work in about 140 days, or until whenever I quit and move on to something else. This equation has no solutions, where a and b are positive constants as no solutions for x. Attempting to solve the equation algebraically leads to the false statement 0 is equal to 8. Find the value of a squared. So, this is telling us that x plus a squared is equal to 0, and x plus b times x plus 2b is equal to 8. So, it's just solving this, we got x plus a is equal to 0, x is equal to negative a. Okay. Then here, what can we do? Expanding this, we got x squared plus 2bx plus 3bx. 3bx plus 2b squared is equal to 8. Sorry guys, heck. Now I could use a quadratic formula to solve this. Sorry. I don't know if that's the right thing to do, because that's going to lead to a huge equation. I could plug negative a in here. Let's try that. So then we get a squared plus negative minus 3ab, no, minus 3ab plus 2b squared is equal to 8. I'm not entirely sure what to do here, because by saying 0 is equal to 8, I'm pretty sure it's basically just saying this is a system of equations where this is equal to 0, this is equal to 8, but I don't know. Because I feel like even though we know that it's 0 and it's 8, we have three numbers where we have we have three variables, but we only have two equations, so we just can't solve it, I don't think. We need some other piece of information to solve this. I don't know what that is. I think it's the fact that there's no solutions for x. I think that's the key fact we need here. But I don't know how to get that. If we plug negative a in here, then this just turns to 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. And if I were to solve, and another issue is that they're positive constants, they're not integers. All we know that's an integer is a squared, because a is a solution. This needs to be a positive integer. So a squared is an integer. But a could be either an integer or square root, or I think that's at least telling us that a is not a fraction, because if a squared is part of the integers, means that a squared is equal to n. So a is equal to the square root of n. Can that ever be a fraction? Can that be a rational non-integer? Like 3 over 2 squared? No. No, it can't be. So a is either an integer or square root. Okay. Hmm. Attempting to solve the equation algebraically leads to the false statement 0 is equal to. So that I'm doing it wrong. I'm doing it wrong because x is a it's like it's not. If you were to attempt to solve it algebraically, we get 0 is equal to 8. These are two um, these are two quadratics. So if I were to solve this or expand this, I get x squared plus 2a plus a squared is equal to x squared plus 3b squared plus 3bx plus 2b squared. Cross out these x squareds, so then 2ax. So 2ax plus a squared is equal to 3bx plus 2b squared. If we were to attempt to solve it algebraically, then that'd mean this has to be equal to this. So 2a is equal to 3b. So then crossing these out, we get a squared is equal to 2b squared. This is 0 is equal to 8. This is the 0 is equal to 8 that we're looking at. So so does that mean that, no, a can't be equal to 0? So then what? So at least we have this here, that a is equal to 2 over 3, 3 over 2b. So a squared is equal to 9 over 2, 4b squared. So b must be divisible by 2. That's what that's telling me. But I don't know what else. What if I just plug that in here? A squared is equal to 2b squared. So then we get a squared is equal to 2 times 9 over 4b. So a squared is equal to 9 over 2b squared. A squared. Bro. Bro. A squared is equal to 2 times, would be 2 over 3a squared. So it's equal to 2 times 4 over 9a squared. So a squared is equal to 8 over 9a squared and see an 8, maybe that can come in handy. So 1 over 9a squared is equal to 0. So a is equal to 0. But this is not correct because there are no solutions to this equation. Confused where we're getting the 0 from. Maybe we're just moving everything to one side, so if we just cross out what we did here, go back here, we say 0 is equal to 2b squared minus a squared. I'm going to say it's like that. So then this is actually 8. So 8 is equal to 2b squared minus a squared. Here are two systems of equations. We get 8 is equal to 2 times, what's a squared? B is 2 over 3a, 2 over 3a squared minus a squared, so we have 8 is equal to 8 over 9a squared minus a squared. 8 is equal to negative 1/9 a squared. Oh, negative 72 is equal to a squared. Where are we getting the negative 72? No, we were so close. We were so close, but yet so far. 2b squared, 2b squared, 2b squared minus a squared, 2b squared. B is equal to 2 over 3a is equal to b. 2 over 3, 4 over 9. 2 times that is 8 over 9. 8 over 9. Oh my gosh. Oh my god. I mean, could I just make everything negative? Would that work out? I'm not sure. Not sure. I'm just gonna guess that it's gonna be positive 72. I'm gonna receive an answer. Be right back. Yes, I was right. Thank goodness. I did not want to lose this winning streak. What I did here was correct, totally correct. That's what they did. Then what I did, I crossed everything out. What I did here was correct. I just plug this into here, and then you were supposed to solve to get 0, and you were supposed to do it correctly, but the answer here is 72. So I guess maybe sometimes just disregard the minus if you can't really figure it out. I got it right. Thank you guys for watching. I'll see you guys tomorrow. Goodbye.